I've spent around 20 years, 18 to 20 years. Yeah, I've spent around 18 to 20 years in the world of data, and in these 20 years, I can tell you I've seen this industry change from being called a decision sciences industry to being called a AI industry to now the Gen AI industry. So feel free to ask questions, and I'll try my best to answer those questions to the best of my knowledge. And if there is any question that I'm not able to tackle or I'm not confident about, I will definitely give you the right references where you can find the answers to those questions. So thank you all, everybody, for attending today's workshop. The recording of today's workshop and today's session would be uploaded on IB Pro Schools YouTube channel, and feel free to refer to that after the session as well. Okay, very good. Thank you. So you can ask any questions on the YouTube channel where it is being streamed, as well as you can ask any questions here verbally with me as well. So does anybody have any question? And I've also prepared in such a way that if you do not ask me relevant questions, then I've got set of FAQs that I can take care of as well. So any questions, anybody? Any questions that you may have? Any questions? I want to keep the agenda very, very loose today so that I give you ample opportunity and time to ask me any kind of question that you may have. All right. So since we're waiting for the first set of questions, let me explain one very simple thing, which is how GenAI works. Yeah. Would you want to understand that as a question, everybody? How GenAI works? What is GenAI? Okay, that is also a good question to ask. So generative AI, Aniket, helps you to generate creative content. So for example, it helps you to generate text, it helps you to generate visuals or images, it helps you to generate videos now, it helps you to generate content, creative content, as we say. It helps you to generate as if a human being is generating. So it tries to mimic human brain to generate content, to generate images, to generate videos, to generate photos. So that's what Gen AI outcomes are, or use cases are. Use cases are generative AI, so artificial intelligence technology that is used to generate something, and hence the name Gen AI. Any other question, Aniket, as a follow-up question to that? No? All right, let me explain how Gen AI then works. What do you think? Anybody who can contribute? How does Gen AI work? Anybody who can contribute to that? What do you think? How does Gen AI work? Anybody? Any idea that you have? Anything? In its simplest form, how Gen AI works is it through supervised learning? Okay, I'll give you a very fundamental example that you can also quote to others as well. Let me open my Excel sheet. Let me open a blank sheet here. Remove the grid lines so that we all can see it properly. So the question is, how does Gen AI work? Now, first, I will give an example. I'll give the process flow, or not necessarily a process flow. I'll give a explanation of how Gen AI works in a very, very layman term. And then if you want, I can go to the architectural components of Gen AI as well. That could be interesting for some people to build it more technical than the others. But to simply explain Gen AI, it's say, for example, if I were to ask you how are, and then I give you a blank here, what do you think will happen? If I gave you a blank, what will happen? What will happen, guys? What will you say? The next thing? how, are, what will come next? So Aniket says that it could be you, and then somebody says it could be you doing. How are you doing? Anything else that you can think of? If somebody says how are and then gives you a fill in the blanks, what else could happen? So we use combination in order to deduce. Okay. So essentially, if you notice, right? I mean, if somebody asks how are and gives you a full fill in the blank, you will probably most probably will say that how are you, right? That is the most frequently used answer that would come after how are, right? So this answer, why do we think that this is the right answer or this is the right thing to explain or to to say after how somebody says how are? This is because how the human brain is designed, because that's what we have experienced, that when somebody says how are, most likely the next word would be how are you, right? Similarly, if somebody were to say that I love eating, then some people will say I love eating donuts, some people will say I love eating burgers, some people will say I love eating dosas or pizzas or whatever that may be the most frequently occurring word. Or it could also be that I love eating dosa with masala, or I love eating pizza with olives, right? So with every when we say Gen AI, we give as a user, this is the input given by user input, right? And this output is AI output. Is that making sense, everybody? This is user input and this is the AI output. Now, how does it really work? Um, so Gen AI, so how does it work, right? So Gen AI is based on something called as supervised learning. Now, supervised learning is not a new concept. We have been using supervised learning for almost donkey years. When I say supervised learning, essentially what it means is that it says, example of supervised learning could be that if it is A, then the next thing will be B. And who decides that? This is the past data. For example, because our brain is saying that when somebody says how are, the next word should be you, because that's what we have seen, that's what we have experienced. So that's what we have been trained. That's what my brain is trained. And similarly, if the past data says that if somebody has money, he or she will spend. Somebody has money, most likely he or she will buy an expensive object, maybe an expensive luxurious car or a luxurious home. So if A happens, then B will happen. That's what the past data says. And that is what supervised learning is all about, right? Because based on historical data, we can say that if somebody has money, then he will buy expensive stuff, right? That is the outcome based on the past data. So that is supervised learning. Now, in Gen AI also, it uses supervised learning on past data to predict what could happen, what is the most frequent or what is the most predicted thing to happen next. So if somebody says, if the input is, let's say if the input A is my favorite place to, and he or she stops. Now the output could be, which is B, and where can the AI model see that output? On historical data, on past data, because that's how the model is getting was trained. That whenever somebody says my favorite place to, then the next thing should be visit. That's the most frequently occurring word on all the past data of text that has been given to Gen AI model to be trained. Then, or maybe my favorite place to visit is Paris. This is predicted based on the most frequently passed data that Gen AI model which has been trained upon with past historical data. Similarly, if somebody says, I'll just take a one step back here. Suppose if somebody says my favorite place to visit. Now, if somebody gives visit as well, or if the output is also created as visit, then the next thing would be my favorite place to visit is, that could be the next most frequently occurring word. And now, if you combine all of that, my favorite place all the way to visit is Paris, right? So, in a very, very layman term, if you think about generative AI, what we do is we train AI system with huge amount of historical content like this, which, and when we say huge amount, imagine hundreds of billions of words, right? And when we have trained this, when we have trained generative AI on hundreds of billions of words, right, it creates a frequency chart of what is the next most frequently occurring word after the previous word, right? So it can actually start from my the next thing, the next most frequently occurring word could be what. So let's say it's favorite, right? So then what is the most next frequently word that it has seen in the historical data, right? Historical data meaning the data, that the hundreds of billions of words that we took in order to train a generative AI model. It We took that data and we fed it into a AI model which looked into it, and it's a very brute force kind of a model whereby it says that if this word happens, then the next most probabilistic word is this, and if these two words happen, then the third most probabilistic word is what, based on historical data. See, I always take a very fun example here to explain GenAI. Imagine there are two couple. They got married at a young age of, let's say, 18 years and 21 years, the legal age, right? They spent, let's say, 50 years. They were married for 50 years, good 50 years. Now, this husband and wife would have had a lot of conversations between them, right? Let's say the husband says that I love eating, if the wife says nothing, right? Or if his husband asks a question to the wife that, hey, can you do this? Now, can you do? And then what is the next thing? In their conversation, if they have lived for 50 years, even before the husband finishes that word, I mean, that question, the wife probably would guess by the end of the good 10 years or 15 years of having spent time with that person. So if you imagine, if you end up recording all the conversations of questions and answers, of responses and re-responses between this couple who spent 50 years talking to each other as part of their marriage, right? And if you record it, put it into a document, right? And then take that document to train an AI model or supervise. Train meaning you then say that if the question is, where are, then the answer is my clothes. Or if the question is, where are my clothes, then the answer is in the wardrobe. If you train with this question and answer pair to an AI model, that is what we call it as model training. And imagine if you have not just one couple, but if you have hundreds of millions of couple conversation recorded somewhere in a digital form, and you take that huge amount of data and then train an AI model with that data, the output would be a Gen AI model, which is really a brute force model whereby it understands what is the most frequently occurring next word is after the first word or after the second or third or fourth word, right? So that's how really Gen AI works in the layman term. Now, so there is a question that Zibran has asked. If we use supervised learning, isn't it same as machine learning? If not, can you please provide the difference? No, supervised learning is a technique used in machine learning. Absolutely right, Zibran, what you said. It is. It is used. It is a part of machine learning. Absolutely right. Right? It's actually supervised and unsupervised algorithms are part of the traditional machine learning algorithms that we've been learning since since we have been using since actually late 90s, especially the supervised algorithms we have been using since the late 90s, or even before that, right? So this is not new. What is new now is the computational power, the amount of computational resources, meaning the amount of computer processing power that we have, the graphical processing power that we have now in the current age that we live in, is humongously more than what we used to have even 10 years ago. And what that has done to us is, what that has done to the AI models, or our capability as humans, our capability to train these AI models, is that it has allowed us to train the AI models with huge amount of data. Now, you see, Andrew Ng, who's supposed to be considered to be one of the very, very advanced researcher in the AI and the Gen AI space, he took a very famous example in one of his talk. He said that earlier, let's say I want to say up until mid 2000s or 2010s, actually, what used to happen was that if we trained a machine learning model, if we train a machine learning model with, let's say, this is the volume of data and this is the accuracy, machine learning model training output. When I say training, it really nothing but, if A happens, then B will happen next. That is called as training, right? If somebody asks, how are you doing? Then the most frequently occurring answer would be, I am doing fine. That is the output of that question. That's how you're training the model, supervised. So there, a traditional machine learning model accuracy with the volume of data would start to tamper down. That used to happen in traditional computational resources, using the computational resources that we used to have up until like mid 2010s. I mean, up until like 2000, mid 2010s. Okay. However, the moment you provide huge amount of resources, this is with traditional computational resources. But the moment you end up providing to the same machine learning models, right? Same machine learning models, same machine learning algorithms. When I say model, meaning algorithm, with huge amount of volume, and you deploy those models on very huge, I mean, very high powered GPU driven machines, right? Which has huge capabilities to compute things. There, what happens is the moment you start doing so, then the accuracy with high volume of data, with on a very fast and very resource heavy graphical processing unit driven machines, when you start training the machine learning models, and then you start seeing the accuracy output meaning the ability to predict what is the next most frequently occurring word based on the past data that you have trained it upon, that started to become highly accurate. But this is on high resource machines. When I say high resource machines, imagine, when we play video games, if you want to play video games, then you want computers which have graphical processing unit, high powered graphical processing unit, you have high power RAM, high fast RAM, then you want very good motherboard. So if you end up giving almost infinite machining computational power to machine learning models, while when you are training them on huge amount of data, then researchers found that the accuracy increased significantly, while traditional computational resources with the kind of machines that we normally used to use up until 2015 or so, the machine learning models accuracies used to start becoming faltered after a certain point, with after a certain volume of data. And when they realize that this is what is happening with when you provide huge computation resources to train machine learning models on huge volume of data, and the accuracy increases significantly, then they found that was a light bulb moment in the AI industry. And then they realized that, you know what, there is no limit. We can train machine learning models with humongous amount of data, and that will end up giving us significantly more accuracy. So the only catch here is that if you own a company which is willing to create a large language model, which is the foundation model, the brain behind Gen AI, then you need to have one very important thing, which very, very few companies in the world currently has, is the availability of high-end graphical processing units, the chips, the graphical cards, the availability of graphical cards, and the machines which can process and which where you can install them. That is the most important thing that you require at this point of time in order to build a large language, in order to build your own large language model. And that is the reason why if you check online, you'll find that there is a company called as Nvidia, which makes the graphical processing units. That company share has quadrupled in the last few months, if not more. I know so many of my friends who had a few Nvidia shares. I had a few of my batchmates working in Nvidia as a researcher, and they had employee stock options. All of them have become millionaires because their stock option, the stock prices have gone significantly because they almost control, Nvidia almost control the chips. So, Adya, you had a question? No? All right. Now, this was a layman overview of Gen AI. Now, is there any specific question as well that you can think of? Or do you want me to go deeper? I can go deeper into the architectures of Gen AI as well, of how the Gen AI models work and so forth. What is the next question that you have? All right, I'll tell you one more thing. So I actually made some of my notes actually, so that's what I'm referring to. I don't like to use a lot of a lot of PowerPoints, so that's the reason why I make my notes. Um, please talk about LLM, and that is the next question that has, if you could go deeper, LLM and how it's used in case of in Gen AI. All right, good, Abhijit. So what I'll do is I'll talk about a little bit of architecture. It could be a little technical for some people, but I'll try to make it as simple as possible for everybody to understand. Yeah. So if I were to draw a block, if I were to draw like suppose this is artificial intelligence. This happened in 1950s. 50s. Okay, that's when researchers started to make the computers mimic as human being. That was the first time that people started to do so. Then came machine learning in 1990s, when people started to use past historical data using statistical models to make or to predict what could happen in the future. Supervised algorithms which predicts what could happen after A is actually part of ML. So you can see how old the core technique of Gen AI is. Then came deep learning. Now in deep learning, what happened was that we got introduced to something called as neural network. Now neural network allowed you to do um, complex data processing, and to recommend decisions which could be a little more accurate, but without telling the reasons behind it. Because neural network, what happens, like in your brain, at times we answer questions that we get surprised as well, that subconsciously how do we know. So in neural network, literally, it almost works like that. It has multiple layers of neural nets where the data goes through. Again, it requires huge amount of data, but not as huge as what we need in Gen AI, large language model. But so in 2000, I want to say in 2000, nearing 2000 and 2008 or 2000, you can say late 2000s. Okay, that's when deep learning started to become a little famous. And then in 2021, Gen AI became famous. And November 2022 onwards, everybody started to recognize because the accuracy had increased, and that accuracy of Gen AI models had increased because of the large availability of computational resources. Now, so this is the history, a little bit of history of Gen AI. But now I'll talk about a little bit of architecture. Okay. Now, the architecture that I want to talk about is a very simple architecture, so that most of the people can actually learn and understand. Imagine these are users, okay, and you have, let's say, you have a web app. Imagine this is a web app on a computer, web application. For example, we all use Google Maps on not necessarily Google Maps. Let's say, for example, nowadays when you use Bing, Microsoft browser, it has Gen AI model linked to it, right? So using a web app, you send a prompt. It could be actually as simple as ChatGPT as well. And when it sends a prompt, it actually goes to a decision model. Imagine there's a decision model. And the reason why I created multiple layers, because actually the decision model has multiple layers in it. Then what does it do is it sends, it actually asks the question to, let's say, we call it as vectorized storage. Now, I'll talk about what is the meaning of a vectorized storage as well, and what does it do. From this decision model, it could actually be asked to a vectorized store, or it could go directly into a general a model as well. For example, Chat GPT or GPT kind of a model, and it can be linked to a web storage, or it could be linked to a, let's say, not web storage. I want to say, for example, some kind of image library, or so we call them as blob storage. Okay. Now here, what is happening is, and then from the blob storage, it can give the response back to GPT. Now I'll tell you, what is the meaning of vectorized storage, and I'll tell you, where GPT is coming into the picture. As a user, let's say you have asked a question, a prompt, to the using a web app. You, as a user, what you're doing is you're using your interface is a web app. For example, I'll, at this point of time, I'll also introduce one. One of the things at Ivy Pro School, we keep investing into a lot of different technologies. So the most recent investment that I have made is that I've created this Gen AI based portal to help any user answer or get answers to legal related question, law related questions. Even if you do not have an access to the lawyer, you don't really need an access to the lawyer. It actually behaves like a lawyer or a robo judge. Okay. Here, you can actually ask a legal query and it'll give you an answer to the legal query. For example, what are the specifics? What are the specific steps to open or to file a public litigation in India? So you ask a question and it gives the answer to that particular question, like a real Indian lawyer will give. This is designed for an Indian lawyer. So this is a web app. This is a web platform. the prompt that I had asked, the question that I had asked is called as a prompt. I'm sure you understand. Now imagine that prompt. Where did it go? So this prompt went to a decision model. Now, what is a decision model here? So in this in this startup that I have invested, so what we have done here is we have not created our own large language model. We have taken OpenAI's specific large language model and we have fine-tuned or we have trained it to behave and to answer as an Indian lawyer. So we actually took a lot of Indian laws and Indian, cases, Indian legal cases, and we trained the OpenAI model to answer using the information that we trained it upon, and not just the information that it had from, from OpenAI. We actually are using their large language model, but we have trained it with our own database. And when I say we have trained it with our own database, which what it means is our own database of Indian laws or Indian cases. So we trained it so that it can give reference to a specific section of Indian laws, not just US laws or international law, but India specific laws. So all the steps and everything that it has given over here are specific to India. And you can also get the Bare Act, you can get the specific sections of this answer as well. It'll give you the references of the sections as well. So that is something called as fine tuning. But how did we and how did we do it? So we took, as I said, we have not created our own large language model. We are using OpenAI's language model, large language model, but we have fine tuned or trained it. And that training we did it using our own data. So our own data meaning, imagine all the PDF documents. We literally took the PDF documents of Indian laws, Indian case laws, and we use those documents. Imagine, you store them in a Google Drive. Okay, let's say 100 GB of them. I think it was slightly more. And then we said that, hey, OpenAI's large language model, please read the documents which are over here, right? And understand, create a frequency chart of all the, or frequency table of all the words which are there. So that if somebody asks, what are the steps to file, to open a new company in India? So answer to that question is somewhere there in one of the laws, one of the Indian laws somewhere, or Indian cases somewhere in this, in these documents. And that information is stored in a vector form in their vectorized database, in their vectorized storage. Who's in OpenAI, because we are using the OpenAI's large language model. So they give us space, we pay for it, they give us space. And this vectorized storage could be also on a cloud platform like Microsoft Azure or AWS. And we have linked that vectorized storage, which contains nothing but the question and the answer, question and the answer. You'd be surprised how the question and answer could look like. Just to give you an example, not the example of, I'm not allowed to give the example of exactly the same one, but I'll take an example of, it's from the internet to explain you how that fine tuning looks like. What is a vectorized storage? I'll explain that as well to you. Give me one moment. I just wanted to show you something. Okay, give me a moment. This is the one. Just to show you what goes in a vectorized store, okay? When I say vectorized store, what goes into it? Look at this message, okay? This is for everybody to kind of see. So we know that, when we use ChatGPT, we give a prompt and it gives a response, right? So what I'm explaining you is that how do you train or how do you fine tune a model, a large language model, right? To behave or to answer in certain way that you wanted to answer, okay? Using the knowledge that you have given and not using its own knowledge. For example, look at this. This is message. Look at this function. Okay, it's not very difficult. I know it's a code, but it's not very difficult to understand for anybody. Role, system, content. Suppose if this is the prompt, Marv is a factual chatbot that is also sarcastic. Okay, this is the system message that we are putting. And suppose this is the user who has asked a question, who's asked this content. What is the capital of France? Now, if you ask this question to ChatGPT, normally the answer to that question would be what? What would be the answer to that question? Everybody knows. It'll say Paris. Very quickly, it'll say Paris. But here, as a trial project, when we were trying to create a chatbot, which is not going to answer only factually. Factual answer is Paris. But we wanted to create a chatbot that is also sarcastic. So we said that please answer like this, Paris, as if everyone doesn't know that already. That is one question and one response that we trained or fine-tuned the model with. Now look at this, because the model requires a lot more data to be trained, not just one pair of prompt and the response. So let's look at the next one. Who wrote Romeo's and Juliet? So suppose if that is a question asked by the user, the answer that we want, the ideal answer that we want it to be given is, oh, just some guy named William Shakespeare. Ever heard of him? So it's a sarcastic output, isn't it, guys? Right? How far is the moon from Earth? Around 300 this kilometer, 300,000 this kilometers, give or take a few like that really matters. So here, if you notice, with these just three responses, question and prompt and responses. Now imagine if there were 100,000 of them, or maybe 1 million such prompt and responses. So you do require a few. You do require a sizable number to be able to train the model. Otherwise, the model will not really understand what you're trying to explain. The accuracy of the model will not be great. So imagine if you have 1 million such prompt and responses, the more the merrier, okay? And you use that data is in a document format. You use that data and link it and start using that data to fine tune a large language model. This process is called as vectorization. Is that making sense? Or this process actually is called as fine tuning. And vectorization is the technical term that is used by large language model to create the most frequently occurring responses to certain questions. And that response table is stored as vectors in a vector in a database format, and that is called as vectorization and vector storage. That vector storage is the analysis of these prompts and responses, and it holds that in a vector form, in a vectorized storage. Is that making sense? So it's really nothing but a kind of a database, you may say, which has the data that if this is the kind of question, this is the kind of answer. This is the kind of question, this is the kind of answer. Is that making sense, everybody? So that is your vectorization or vectorization storage. Okay, let me go through my notes if I missed out anything. So query, sentence transformation, vector. Okay, yeah. So actually, vectorization is really nothing. Again, the same thing. So you give the query, you give the response to it, and then it understands that for this kind of a query, what are the most frequently occurring responses, and then it stores that pair in a vector form in a storage, in a database, you can imagine. Let's go back to this visual here for a moment. So here I've given two options, A or B. Imagine if it is a general purpose model, for example, ChatGPT, right? ChatGPT is using OpenAI as a specific model, but it is general purpose. Anybody can ask any kind of question. It is not specifically trained to answer in a sarcastic way, or it is not trained to answer as a Indian lawyer. It is trained to answer like an AI, normal AI model. Here, if it is general query, it can also go to a general purpose transformation model like ChatGPT and get the answer either from just get the answer from its own pre-trained model. Whereas vectorized models are purpose driven, are trained for specific purposes, right? So if you notice here, there are two career options. If you were to ask me, there are two career options. The first career option here is that you can actually you can become part of this process. This kind of a process is going to be, you will see in the coming days, if not already, there are so many companies which have startups which have come and gone into this space, which are creating purpose-driven models or which are training the model for a specific purpose. Imagine you want to assist a doctor to understand the all the medical history of all the patients that may be there in a large hospital system. So you want to train, fine tune the model in such a way that it understands most of the medical terms used by, let's say, Indian doctors or used by, let's say, an American doctor, right? By training on those medical journals and those medical literatures and images and whatnot, which are specific to, let's say, India or Indian medical system, right? Storage it in a vectorization, vector form in a vector storage, and then tell the LLM to use this, that to use anything else, right? So there's going to be a very huge opportunity, and there's already a huge opportunity of people who understand how to fine tune, how to create vectorization, how to create a purpose driven large language model using the language models which are already created by mega tech companies like OpenAI or Google's Bard or Meta's LLM, I mean Meta's Llama, and so many of them, right? So that is one career option which is technical and at the same time is going to be high demand. But it's not as complicated as creating your own large language model. The decision model that we're talking about here can be pretty complicated as well because it requires huge amount of pre-training using using high computational or very, very high computation resources. And those computation resources are the main scarcity point here right now. That is the most premium thing for now. I think they're going to become costlier than diamonds because everybody is looking for computational chips. And that's the reason why if you want to invest into stocks like Nvidia stock or similar companies after doing your own research, because those are going to be the most difficult thing and most expensive things. So a lot of companies, what they're doing is, and a lot of startups and companies, like for example, for us as well in this time to justice.ai. By the way, you must try it, guys. Okay, you must try it. And if you need more free option, just let me know. I'll give you. You can try it for free up to 1,000 words. But if you need more, you can just ping me and I can give you some more VIP accounts. But it's very interesting the way this works, and it works very smoothly. You can actually literally ask almost any question and it works like a charm. Okay, how do I file, let's say, an FIR? So this, and we created this entire thing with a team of only 4 resources or maybe 5 resources, and we did it in less than 4 or 5 months. And this could become a huge opportunity. So this is also a great opportunity for anybody to get into, right? So this is one career option that one may consider, right? The second career option is that you become a generic prompt designer, because prompt design, although this career option, I don't recommend unless you really, really want to remain very, very non-technical. Prompt engineering is essentially using your domain understanding of, let's say, if you want to create prompts for financial modeling. So if you have understanding of prompts, if you have understanding of financial modeling, then you can actually structure the prompts in such a way that it gives very, very proper answer without the user having to spend a lot of time with ChatGPT. We all have spent a lot of time with ChatGPT, and at times it gives weird answer unless we keep refining it, and so we keep refining a prompt. So there are specialist prompt engineers now who use certain steps to design the prompt in such a way that in first prompt itself it gives the right answer. But it's a highly technical, non-technical job unless and with the domain understanding of a particular domain. I don't really recommend unless you really want to remain very, very non-technical. The most technically heavy job, I would say, is is of a person who wants to actually create a complete large language model as well. Then you need to know a wide variety of stuff, especially computational algorithms and so forth. But you had a question. Okay. Now we have a few minutes remaining. So I want to take these few minutes and open the ground for more of your questions. What more questions do you have? And I'll be more than happy to answer them. Where does data engineer come into the picture here? Data engineers are going to be highly in demand. The reason is that this entire flow chart the workflow that I told you about, Aniket, it cannot happen unless the data engineer sets up the entire data infrastructure. You need you need the infrastructure to store the vectorized data. You need infrastructure to support the large language model. You need infrastructure to support the web app and the users you're using it, then the demand that they're going to generate. The data engineers are required across this entire workflow because those are the custodians. Those guys are the custodians of this entire infrastructure. Maybe they're not really worried about how things are happening, but they are worried about actually they are worried about how data is flowing, but not so much as, for what purpose are you creating the vectorized stores, or for what purpose you're using. Okay, some people are. So what purpose you're using these things for? But they are the custodian of the entire infrastructure. Without them, this infrastructure cannot work. So if you're tech savvy, and in our data engineering course at the IB Pro School, we actually focus on creating this entire ETL pipeline, extract, transform, load pipeline on cloud. The only thing remember is that you want to do most of the stuff if you are a data engineer, that you want to do things, you want to learn things, how you want to learn how to do things on the cloud. Recently, we have collaborated with IIT Guwahati and we have launched a data engineering program, 11 months PG data advanced certification program with IIT Guwahati. And there, the focus is mainly on making you learn how to build that entire data pipeline on cloud. All right, there's another question that somebody has asked. Can there be, since you get neural network, I want to know what occurs in the hidden layers. Is it yeah, Gibran, the what happens in the neural network is one of the most complex topics to explain, Zebran. Okay, and it's not that easy to also understand. But you see, I mean, because unless unless you want to, because nowadays what has happened is there's a lot of abstraction that has happened. You can just use neural nets as library in Python, so you don't really need to know what exactly is going on behind the layers. And frankly telling you, very few people really understand. But you see, it's a game of computation. The more data you give to a neural net driven model, the more accurate result it gives. If the data is given with on a if the neural net model is working on a high computational resource, right? So that is the most important key to understand. So if I were you, I would focus mainly on understanding how to use those Python libraries, which will help you to invoke neural nets instead of going too much into the details of how neural nets actually work for now. Is it same ML algorithms, linear regression, SVM? No, they're not. They're not. What else? What else is your question? Now, there's one thing that I would recommend, okay, if I were you. I know most of you have not asked me this question, but if I were to explain some quick steps to make a career in the current world of AI, okay, then I would say that I've divided this into three phases, okay. In phase one, it's about mastering certain concepts, and this considering the future, okay, to ensure that you protect your future. You want to become slightly more technical than just a user of chat gpt kind of a model. You want to master certain concepts, okay. Remember, gen ai is not, it's technically complex concept. It's a pretty advanced concept. However, because of the so many no code and low code solutions available, it has become much easier to kind of understand. But there are certain basic concepts that I always recommend if somebody is interested in the data and the AI industry, okay. One, and since this is This is not because we have all these courses, but this is based on the official learning partners that we work with. Honeywell, Tesco, Genpat, Accenture, all these companies that we work, Tata Steel and whatnot. We work with continuously. We work with their AI teams. We work with their GenAI teams. We work with their data teams. And I can tell you that these are the fundamental concepts which are definitely required for anybody who wants to make a career in data and AI. One, understand the basics of a few things. For example, linear algebra, probability theory, because I've been talking about probabilistic. What is the next probability of the word to occur? So probabilistic theory, very not very difficult concepts to learn from maths. Okay, not very difficult concept, but do learn that. Don't be afraid of learning Python or at least one programming language. And Python is the most important language to learn. Python and maybe and SQL, most important language. Okay, to learn at this point of time. Data structure and algorithms which go into coding into anything. Believe me, they are not difficult. My daughter, who was, I think, when the first time when she learned coding, she was in third standard, and she, by the end of 6 months of her doing things, she had built 40 plus apps when she was before fourth standard. So it's not difficult. Okay, it's pretty logical. So understand those are considered basic and foundation. Do not be afraid of it. Learn machine learning, supervised algorithm, unsupervised algorithm. Again, they're not very difficult to learn nowadays. Okay, do learn them. The third thing is, and also practice implementing on data sets. A lot of data sets are there in our Ivy Pro Schools data science course. We make people work on 40 plus cases and projects. So the more you work, the more confidence you get with these data machine learning concepts. Data handling and pre-processing. Still, we get so many job opportunities to our Ivy students on data handling and pre-processing to ensure that data is ready for machine learning concepts. Explore deep learning concepts, but only once you have mastered the initial concept that we spoke about: Python, SQL, some bits of math, some bit of machine learning. Okay, deep learning. Again, deep learning frameworks such as TensorFlow, Keras, PyTorch, any one of them, master at least one of them. Okay, experiment with some pre-trained model, learn transfer learning techniques, and so on. Again, not very difficult nowadays to learn. Then NLP helps you to understand how natural languages are processed. When you and I ask question like what how to file FIR in India. Now that is a natural language, but that gets converted into a SQL language, and that happens through NLP. So again, not difficult nowadays to learn. So that is the first thing. First, master these things. Okay. Second thing is gain practical experience. As much of practical experience as possible. Gain experience with cloud. Gain experience with data tools and ML ops, machine learning operations. These are this can be part of data engineering as well, but these are very very important things. Okay, cloud, everything happens on cloud, so it's also very important. Work on real world projects. In Ivy, we make people work on, in any other program, we make people work on at least 30 plus cases and several projects and internship projects. Please do these things. Very, very important. Okay. This helps you to market your skills. And the third is to become your own marketer. The best marketer for your own skills is you. So build a portfolio of projects and cases, then start networking, start letting people know. In Ivy, we make it mandatory for our learners to post things on YouTube and post not just random things. We train them on how to create short videos of 2 minutes to 10 minutes videos on their projects. We train them that how to periodically keep posting on LinkedIn and keep creating YouTube tutorials or blogs, and we give them space as well. Ivy Pro Schools YouTube channel, we maintain a student playlist. Most of our content actually is created by students as well. Some of them are good. Some of them may not be as great as maybe a professional would, but we are proud of our students' content, and we believe, and we have seen so many times that our expert created content versus a student created content. At times, the student created content is more famous than expert created content on our YouTube channel. And we give that opportunity to our learners. And if you are part of one of our students' community, do take this opportunity again. Many of your people do it, but everybody, I always recommend everybody to do it. If you're not part of a student community, this is one of the very important learnings that you want to take away today, that you want to become your own marketer and you want to build your content and then network using social media, specifically LinkedIn. All right. Thank you, everybody, for attending today's session. There is one YouTube link from our YouTube channel, if I may, if I were to give to you, would be a YouTube channel. I mean, a link of. So, by the way, one, if I were to say, I would recommend everybody to go through timetojustice.ai, my new startup, and do give me a feedback. Okay, guys, my email address. And one more thing, if you want to get connected with me, then LinkedIn is the most preferred way of getting connected. Just search Pratik and Ivy, and you'll find the first link will be my link, and I'll be more than happy to connect with you all. I've given it in the chat window as well. Feel free to get connected with me on LinkedIn. And uh, one particular video I would recommend how to make a career in AI. This is the video that I'm going to recommend you all to also watch. All right, some of you are asking when would you receive the certification. By the end of the week if you have attended both these sessions. If you missed yesterday's session on how to use GenAI in Excel, you can always watch it on Ivy Pro Schools YouTube channel as well. So guys, do subscribe to our Ivy Pro Schools YouTube channel if you have not done so already, and do hit that bell button. And if you want to be connected with me, as I said, LinkedIn is the most preferred way. Feel free to just send me a request, and I'll be more than happy to take care of any of your questions that you have. And I'll be more than happy to answer any questions related to the data and AI world at all. Thank you, guys. I hope you had a good time today. Thank you, everybody.
Thank you, Pratik sir. Thank you, participants, for being here today. Hope you got good inputs, good insights. All the counselors for the respective city will get in touch with you with the offers and course details if you are interested. Looking forward to be in touch with you. Thank you.
Thank
Please
you,
fill the
everybody.
feedback form. Thank you.
Bye bye.